This is a video from section 3.9 and it's on related rates. And this is the baseball diamond problem. A baseball diamond is a square with side 90 feet. A batter hits the ball and runs towards first base with a speed of 24 feet per second. Part A. At what rate is his distance from second base decreasing when he is halfway to first base? Part B. At what rate is his distance from third base increasing at the same moment? So we're going to look at part A first. So we draw a baseball diamond, and here's the batter. All right? And we're going to draw from second base, which is up here, down, and we're going to let that distance be x. So x is the distance between the batter and second base. And we're going to let y be the distance from home plate to the runner. So forgive me in advance, I don't know if home plate's one word. I don't watch a whole lot of baseball. But we know dy dt is equal to 24 feet per second. So that's given in the problem. If you look back, it's saying a batter hits the ball and runs towards first base with a speed of 24 feet per second. And so the batter is running this way. So dy dt is 24 feet per second. Now, if the distance between home plate and the runner is y, then the distance from the batter to first base is 90 minus y, because y plus 90 minus y is the same as 90, right? And you have to get a total of 90 feet. Now, we have a right triangle. Now, this side never changes, by the way. That side is always 90 feet. So we want dx dt when y equals 45. Now, from the Pythagorean theorem, this is what we have. We have 90 minus y quantity squared plus 90 squared is equal to x squared. And then what we're going to do is we differentiate both sides with respect to t. Okay? So you're always differentiating with respect to time. And so on the right-hand side, we get 2x times dx dt. And on the left side, we get 2 times 90 minus y times negative 1 dy dt. So I applied the chain rule. But don't forget, we have to take the derivative of y with respect to t. Now, the 2's cancel. Okay? And then what we have is the following. We have x dx dt on the right-hand side. On the left-hand side, I distribute the negative 1 in, and I get y minus 90 dy dt. So now, I'm going to plug in y equal 45. And so I get 45 minus 90 times 24 is equal to x times dx dt. Now, I want you to notice that we are looking for dx dt, okay? But we need x. And so what I'm going to do is I'm going to go back to this equation. And that's exactly what I did. So we know 90 minus y quantity squared plus 90 squared is equal to x squared. I'm going to substitute y equal 45. Why? Because he's going halfway to first base. And so 90 minus 45 squared plus 90 squared is equal to x squared. And so if you notice, when I solve for x, I get 45 times the square root of 5. And so here's what we have. If we go back, this whole thing ends up being negative 1,080 when you multiply it out. Okay? And so we get negative 1,080 is equal to 45 root 5 times dx dt. If I solve for dx dt, I get negative 24 over root 5. When you get a negative, that's telling you that it's decreasing at a certain rate. And so in context, what you can say is the distance between the runner and second, that should say base, by the way. The runner and second base is decreasing at a rate of 24 over root 5 feet per second. Now, for part B, so we're going to let Z equal the distance between third base and the runner, or the batter. And we know still that dy dt is 24 feet per second, and we want dz dt when y equals 45, so it's the same conditions. But the difference is we're looking at this right triangle. So over here. A little bit easier in some respects, because here y squared plus 90 squared is equal to z squared. And again, we're going to differentiate both sides with respect to t. And so 2y dy dt is equal to 2z dz dt. The 2's cancel, so 1080. So again, I'm replacing y with 45 and dy dt with 24. So 1080 is z dz dt. And so you can see I'm old school here. I figured out 1080 the old way. So we need z. So we're going to use the equation y squared plus 90 squared is equal to z squared. We know y is 45, so I plugged it in. If I solve for z, I get 45 root 5. And so what that tells me is 1080 is 45 root 5 dz dt. And I want to get dz dt by itself. So I'm going to divide both sides by 45 root 5. And so I get dz dt is 24 over root 5. In context, what that's saying is the distance between the batter and third base is increasing. Why is it increasing? Because we got a positive value, right? So it's increasing at a rate of 24 over root 5 feet per second. And that concludes this video for section 3.9. This is the baseball diamond problem. Okay, thank you.